Okay guys, here in 2-4 we're going to be discussing the zeros of a polynomial. And so there are two statements we want to look at here. And so if you have a polynomial function of degree n, then these two statements have to be true. Okay, so number one, the function has at most n real zeros. So it cannot have any more zeros than the highest power, the degree of the highest power, right? So if it's quadratic, it can have at most 2 real zeros. If it's cubic, 3. If it's x to the 5th, degree 5, it can have at most 5 real zeros, and so on. All right? Now, that doesn't mean it has to have that many, just depending on where the graph is, but it can't have any more than that number. And also, number two, the graph of f has at most n minus 1 relative extrema, okay? Maximum or minimum, right? So it'll have one less, okay, at most one less relative extrema. In other words, when you count up the max and the min, however many that you've got there, it's got to be at most one less than that power, degree power, okay? Now, here's another chart that we want to look at. Okay, so if f is a polynomial function and a is a real number, then the following statements are equivalent, right? So what that means is, when we read through this, think about it like this. If a fits one of these statements, then it will fit all of them, right? So if one of them is true, all of them will be true. Okay, so number one, x equals a is a zero of the function. Okay, so if a is a zero, then x equals a is a solution to the equation. X minus a is a factor of the polynomial, and a comma 0 is an x-intercept of the graph of that polynomial. All right, so all four of these things are true, right? So if we have a value that's a 0, okay, then x equal that value is a solution to the equation. X minus that value is a factor, and that value comma 0 is an x-intercept. Okay, so keep those statements in mind. All right, so what are we actually going to be asked to do here? So the first problem that we come to is one where it asks us to find all real zeros of this function. All right, so the question is, how do we do it? Well, algebraically speaking, you can find the zeros. They occur at the place where the y value is 0. Because think about the graph. On the graph, if the y value is 0, it's got to be hitting the x-axis, right? And so the zeros, the real zeros, are the places where the graph crosses the x-axis. So if I wanted to figure out what those zeros are, I would let my y be 0 and rewrite the equation. 0 equals x to the 3rd minus x squared minus 2x. All right, so now, if I wanted to find the zeros of this polynomial, I need to start factoring it. So the first thing that I can do is I can factor out an x out of all these terms. So I'm going to pull an x out of here, and then I'll be left with x squared minus x minus 2. All right, so all I've done is I've factored an x out of all three of those terms, right? Now, the next thing that I'm going to do is I'm going to set my attention toward the trinomial right here inside the parentheses. This can also be factored again into a product of two binomials. And so again, when we're factoring this, remember the first term has to be x times x, or the first two terms multiplied together, the first two blanks multiplied together got to give me x squared, I should say. Now the last two have to multiply together to give me 2, right? Now let's think about what our signs have to be. And so in order to get a negative here, I've got to have a positive times a negative inside my parentheses. That's the only way that I can get the last term to be negative. Now, take a look at the middle term. Okay? First of all, the numbers to get this would be 2 times 1. That's how I can get 2. Now, my middle term is negative. So what that means is I want my largest of those two numbers to be negative in order to make the negative term correct in the middle. So I'm going to put my 2 here and my 1 here. And if you wanted to double check it, x times x, x squared. 1 times negative 2 is negative 2. But 1 times x combined with negative 2 times x makes negative x in the middle. So x minus 2x is negative x in the middle, and we've done it correctly. All right? So now, once you have it factored to this point, we can now use the zero product rule to figure out what our zeros are. So any value that I can plug in for x that would make any one of these three terms 0 would be a solution to the equation. Okay? So for this one, if I plug in 0, that's 0 times all these out to make 0. So one solution would be x equals 0. A solution here would be -1. -1 plus 1 makes 0. And the solution for this one would be +2. So those are my three values of x that would make this equation equal to 0. So now all I have to do is take those three values and turn them into points. So 0, 0 would be a point. -1, 0 would be a point. And 2, 0 would be another one. So these are my three zeros for this particular function. Because remember, if I have the x value of the 0, then the y value is always going to be 0 because it's at the x-intercept. All right? So there you go. Those are your three answers, your three solutions. Okay? A few more practice problems we want to look at here. Okay, again, we want to find all the zeros. And it also says relative extrema, so we'll look at that as well. So once again, I've got my equation. I'm going to set it equal to 0, or set the y equal to 0. -2x to the 4th plus 2x squared. All right? So now, once again, I need to start factoring to determine what my zeros are. And so the first thing that I'm going to factor out here, okay, is a -2x squared. All right, so again, when you're factoring out like this, you want to see what's the biggest regular number I could pull out. Well, I can pull out a -2. And I'm pulling out a -2 so that this leading term can be positive, is the reason why I'm pulling the negative out of there. Now, what's the highest x I can take out? X squared. Okay, so when you're trying to figure out what you're able to factor out, do the numbers first, then do the letters second. Okay? Now, I've got a parentheses here. Well, let's see what's left once I divide -2x squared out of there. Well, the 2's cancel, they're gone. 2 of the x's cancel and just leave me with x squared. Okay? And then from here, positive and negative, that'll be a minus. And when I divide 2x squared divided by 2x squared, that just makes 1. And why am I saying dividing? Because remember, it's the opposite of the distributive property. If I multiply this out to get here, then I have to divide this out to get down to here. So they're opposite. Distributive property and factoring are opposites, right? So distributive property is multiplying, so factoring is dividing the terms out. Okay? Let me see here. What else can we do? This now can be factored again. So that's 0 equals to -2x squared. And so I'm going to factor that. And so x times x is x squared. And so I want this to be -1, the ending term. So the only way that can happen is a positive times a negative. So go ahead and write your signs in. And 1 times 1 makes 1. It checks out in the middle because 1x minus 1x is 0x, no middle term. All right, so we factored it out correctly now. And so our next task is to see, by the zero product rule, what values of x would make these terms 0. If I plug in a 0 here, 0 squared, 0, 0 times -2, 0, and 0 times whatever these other things are is 0. So 0 would 0 it out. Here, if I make this a -1, that would 0 this one out, which would in turn 0 everything else out. And here, if I just plug in a 1. So those are my three x values that would be zeros for that equation. And so now I just want to take them and turn them into points. 0, 0, -1, 0, and 1, 0. Those are all of the zeros for this particular polynomial function. All right, so relative extrema we can do by graphing it. And so what I'll do is I'll erase this last one off of here. And we'll put the new one in there. So it's -2x. This is raised up to the 4th power. Okay, I'm going to come out of the power, do plus. Let's see, plus what? plus 2x squared, 2x squared. All right? And so with the graph of this thing, the first thing that I can probably do is go in and verify my zeros and make sure that they're correct. And as we can see here, they are, because they occur at 1, -1, and 0. So we can use the graph to verify that my zeros are correct. Now remember, the other thing that it wanted was all the relative extrema. And so again, another good thing about the Desmos calculator is it already puts up all of your points of interest. So here's an extrema, so that would be 1. 0, 0 is actually 1. And then this is also another one, all right? And so those would be all the relative extrema. It didn't ask us to differentiate between maximums and minimums, or that's the incorrect plural, maxima and minima, right? So all we would have to do is list those 3 points out and say those are your relative extrema, all right? Last one. Okay, so state the number of possible real zeros and turning points of this. All right, then determine all the real zeros by factoring. Okay, so again, as far as possibilities, then we want to look at the power, right? So if we wanted to state the number of possible, well, it can have 3 possible and 3 possible turning points, right? So turning points is the easy language of saying relative extrema, right? So that's 2 different ways of asking, okay, the same thing, all right? So let's go see now if we can find the zeros of this thing. So once again, 0 equals x to the third minus 5x squared plus 6x. Okay, once again, we're ready to attempt to factor it. I see that I can pull an x out of all of these. Can't pull any regular numbers out of all 3 of them. So that'll be x, open a set, left with x squared minus 5x plus 6. All right, next step. Let's see if we can factor this parentheses into a set of 2 binomials. And so we can. This will be x. This will be x. Now this number is positive. So this is either positive times a positive or a negative times a negative. How do I know which one? Look at the middle term. Middle term is negative, so this has got to be negative times a negative. Now, I'm looking for 2 numbers that multiply together to get 6, but at the same time, they combine together to get -5. Those 2 such numbers would be 3 and 2. Oh, whoop, 3 and 2 is what I need, right? All right, so -3 times -2 is +6, and -3x and -2x is -5x in the middle, so we factored it correctly. Now we can get our zeros. It would be 0, +3, and +2. And so the last step is to actually write out the points of the 0, the coordinates. So that would be 0, 0, 3, 0, and 2, 0. And that's it. Quiz waiting for you. I'll see you in class.